Welcome back to week 3, and in this last video, video 4, we will talk about how humidity and dew point will vary. We'll talk about how it varies by location and how it changes over time, and then a little bit about the causes. So we're going to look at a series of graphs here. These two graphs that we see here, these are from April 8th, 2013, and for the Hood River area. These are showing daily variations in temperature in the blue, by the blue line, dew point in the red, which the red is going to be the bottom line, the blue is the top. Time of day, so this is going to be in military time, and then in variations in precipitation. The dark gray area showing you where we have the sun set, so it's nighttime, and then the lighter gray is going to be during the day. So we see what we expect based off of last week's material, that we have cooler temperatures at night, warmer temperatures during the day because the surface of the earth is heating up. We see change in dew point here. As our temperature increases, our dew point is going to increase. If we also take a look here at where we have precipitation occur, granted, this precipitation is forming well above the Earth's surface where this station is recording its data, but when we have this precip occurring between 15 and 2100 hours, 15 to 2100 hours, we see that our temperature and our dew point temperature are pretty close to the other in comparison to when it was drier. Welcome back to week 3, and so if our dew point temperature line crossed our outside temperature line, we would know that it would either be foggy outside, the rain would be produced right at that point, or maybe we'd have frost, clouds rolling in. So where those two lines would cross, that's where we have that condensation occurring. And at this site, like I said before, they don't cross at this point because the precip, in this case, is coming from a cloud that's located above this station, not actually at that station. So if we look at variations in a week, we can see the same week here. This is for the 5th. Our first few days are clear days, so our outside temperature, this top line in blue, high variation, and then we get a low variation because it's cloudy. And our dew point temperature, we see the same thing. We see it vary significantly when it's clear out, and we see it not vary quite as much when it's cloudy because we have that clouds forming, so our dew point temperature isn't going to change very much. It's going to be pretty close to those two. And here, these 2 days, these 2 evenings, these lines cross at the station, and this one as well. That probably means that we had dew or frost, depending on the temperature. It looks like we're not below 35, so I don't think it was frost. It was probably dew that formed on those days. And then later in the week here on the 4th, 5th, 6th, we see those lines getting really close together because it is raining. And so that rain's forming up in the cloud above this station. Pretty cool. So we can also, here's another graph showing the same thing, different span of time. This is on the 8th, ending around the 8th, starting on the 1st. And you can see a few spots here where those two lines cross, meaning we had dew on the surface. And we can see on the 5th, 6th, 7th, 8th, we see those lines get really close to the other because we had lots of rain those days. And our clouds were probably a little bit closer to the surface. So looking at variations in humidity, humidity can vary by location. Areas near large bodies of water tend to be more humid than landlocked areas. There are some exceptions. Variation can occur over time, daily. So just like dew point can change over a day, we can see humidity changing as well. And this is because we're changing the temperature of the air, so we're changing our relative humidity. We can see humidity decrease during daylight hours because of that increased temperature, and increase at night because temperatures are dropping. We can also see an increase while storms roll through an area because we have more humidity present, more water vapor. So if we take a look here, here's a humidity graph showing you the relative humidity in a 24-hour span of, or close to 12-hour little over 12-hour span of time, starting at 12 a.m. on April 8th. And we can see started out at 90%, pretty high humidity, and then it's been slowly, gradually dropping throughout the morning hours, because around this time frame here, the day before this 90% relative humidity, we had rain occurring at that location. So if we compare our temperature, our precip, and our humidity, this white line on this graph is showing you when we have our 3 a.m. time frame. So this white line corresponds with the start of this graph. So 3 a.m. is going to be, 3 a.m. will be right here. So as we see our temperature increase for the day, we see our humidity decrease, and that's because our temperature is increasing. We are able to hold more moisture in the air, so our relative humidity is going to go down. And here are daily humidity variations in 3 days, temperature variations. We can see high temperature. This is our maximum temperature for each day, and then we have our max dew point in orange, minimum dew point in yellow, minimum temperature in blue, and then here we have max, min, and average as well. So humidity is a hard thing to get the average for the day, because if you look, at nighttime you have a low, during the day you're going to have it being higher. So these two are max and min are showing you how it's changed in that day. Pretty dramatic change from 30% to 90%. So this one was probably a point in the evening. This would be during the warmest part of the day, because we have a higher temperature. Our warmest temperature is 70 degrees for that day. Pretty warm temperature, lots of energy in that air to be able to hold more moisture. So because the air can hold more, we have a lower relative humidity. So to go over causes in our changes in relative humidity, we've got temperature. So how much energy exists to evaporate water into the atmosphere. If we have higher temperature, water can hold more air, so our relative humidity is going to look lower. And also the amount of water that's available. So if you don't have water available, you can't have a high humidity. So that kind of wraps up humidity and dew point and how it changes over time and location. I will see you in lab.